All right, Unit 7 for Intermediate Algebra is all about factoring. Now for Lesson 7.1, we'll be looking at monomials and factoring. Some of our key terms: factored form. A monomial expressed as a product of prime numbers and variables in which no variable has an exponent greater than 1. So we've used greatest common factor before. We've used prime numbers or prime factorization to discuss or display different numbers. Now in our monomials, this will just also include all of the variables that have to go with it. And we will see that in a couple of our first examples here. Second key term, greatest common factor, the product of the prime factors common to two or more integers. Today, for what we are interested in, instead of calling it integers, call it either numbers or monomials. Oops. We're looking at things common to monomials. We're not necessarily too concerned about integers today because those would just be the constants, but we want the whole monomial. So let's look at what this looks like for us. If we have, for looking for monomials in factored form, in our first example, we have the monomial negative 25 x cubed y squared. Well, the first thing to look at is always your coefficient part. If we look at this negative 25, first thing you could always pull out is a negative 1. Because we have a negative, take out the negative 1 right away. So now it's negative 1 times 25. Well, that 25 can be broken down even more into 5 times 5. So just our coefficient part here, we can call it negative 1 times 5 times 5. That's broken down into its prime factors as much as it can go. The next piece, we'll look at our x term. We have x cubed, which, as we know, is just x times x times x. And of course, our last piece, the y value, we have y squared, which is just y times y. So this piece here, negative 1 times 5 times 5 times x times x times x times y is our monomial in a factored form. Let's try it again with example B here, 36a squared b. Looking at 36, we can break it up into 6 times 6. Well, this 6 we can break into 2 times 3. This 6 can be broken into 2 times 3. And those are our smallest prime factors there. So just the coefficient part becomes 2 times 3 times 2 times 3. Then again, we look at our a value. We have a squared, so that is a times a. And then lastly, we're looking at our b variable. There's just one of them. It's like a b to the first power times b. So again, our factored form would be 2 times 3 times 2 times 3 times a times a times b. Now, in other classes, we may have done, made it look like this, 2 to the second power times 3 to the second power. That would be our prime factorization. For our purposes today, let's just spell out all of the prime numbers. So 2 times 3 times 2 times 3 instead of 2 squared times 3 squared. We will spell out every single one. All right, next example, we have 34y cubed z to the fourth. Again, like before, the first thing we always look at is our coefficient. We can break that up into 2 times 17. Well, 17 is prime and 2 is prime. Neither one of them can break down any, so that would just be our numerical part. The coefficient part would just be 2 and 17. Next piece we need to look at is our y value. We have y cubed, so that one would be y times y times y. And then we look at our z value, our z part, z to the fourth is z times z times z times z. So this would be our factored form of that monomial. And this will be very helpful in finding the greatest common factor that you'll see in our next slides. For example D, I want you to try this one on your own. Take a second to pause the video, see if you can find the factored form of negative 52c cubed d squared, and then replay the video and see if your answer matches up with mine. So I'll give you a sec to pause the video. Hopefully you've tried this on your own now, so let's check and make sure that your answer matched up with this one. We always start with this coefficient, this negative 52, so we have to pull out negative 1 first off. That's negative 1 times 52. Now 52 we can break up into, I'm going to do this over here, 52 we can break up into 2 times 26, and 2 is already prime, so I'll put a little underline there. 26 is not, though. That can be broken up into 2 and 13. 2 is prime and 13 is prime. And we had that negative 1 that we needed. So, oops, just our coefficient part, we're going to need negative 1 times 2 times 2 times 13. The next part we look at is our C variable. There are 3 of them. Next thing we look at is our D variable. There are 2 of them. So there should be 1, 2, 3 C's and 1, 2 D's. So this would be our factored form. Negative 1 times 2 times 2 times 13 times C times C times C times D times D. This would be our factored form of that monomial. For our next examples, we're going to be looking at finding the greatest common factor of a set of monomials. As kind of a hint, the first thing you should do is find the greatest common factor of the coefficients. Then you can always just use the lowest power of each variable in the monomials. So this is kind of a shortcut. I'm going to show you the long way, or the long method. This will be using the ideas that we just looked at. So we'll be looking at this, the monomials in factored form, and using those factors to find the greatest common factor. So for A here, we have the set of numbers 21 and 49, and we need to find the greatest common factor. Well, 21 is 3 times 7. These are the prime factors for it. And 49 is 7 times 7. Obviously, we can definitely notice 7 occurs in both. We just have 1 7 in each of them. So the greatest common factor is just 7. Nice and easy. In our next example, we've got, oops, I should do this one in green. Our first monomial is 12a squared b squared c. Our second monomial is 18a b cubed. So, just like in our last set of examples, our first monomial here, 12a squared b squared c, we can factor out, get into factored form. 2 times 2 is 4, times 3 is 12. That's where these numbers came from. A squared, so a times a. B squared is b times b, and c is right here. So this is the factored form of our first monomial. Similarly, 18b cubed. Well, 18 is 2 times 3, which is 6, times 3, which is 9, or oops, would be 18. 2 times 3 is 6, times 3 is 18, times a, just 1 there, times b times b times b, 3 of them. So this would be the 2 factored forms of our monomials. Now within each monomial we can see here's a 2, here's a 2, here's a 3, here's a 3. It happens in both of them. Here's an A, here's an A. Now again, this one has an extra A, this one does not, so we can't take another one. But they both have at least one B. They also both have a second B. So now we need to multiply all of these pieces together to find our greatest common factor. So 2 times 3 is 6, times A is 6A, and B would be B squared. So our greatest common factor, 6AB squared. The 6 came from the 2 and the 3. AB squared, A, B, B. Now, this is again the long way to do it. As a shortcut, if you can recognize the greatest common factor of our coefficients, 12 and 18, that greatest common factor is 6. That's right there. The lowest power of each variable, the lowest power of A, would just be 1, happens right there. So 1. The lowest power of B is 2, happens right here. And the lowest power of C would actually be over here. It's kind of like we have a hidden C to the 0th power. That's why we don't see it. So we'd leave that C to the 0th power. Kind of over here, it's like, again, it's hidden, so we don't really need it. So 2 ways to do it. You could spell it all out in the factored form, or just recognize the greatest common factor of our coefficients and the lowest power of each of our variables. So let's try example C together. This top monomial, or the first monomial, becomes 6yz to the 4th. 6 is 2 times 3. Y is just y. Z to the 4th is z times z times z times z. 18xy would be 2 times 3 is 6, times 3 is 18, times x times y. Looking at our factors here, we have 2 and 2 happening in both. We have 3 and 3. We have y and y. And that is it. Those are the only common factors to each of them. So multiplying those together, 2 times 3 is 6, times y would just simply be 6y. For the last example, D, I want you to try this one on your own. See if you can find the greatest common factor of 40abc squared and the monomial 50a to the 5th, b to the 3rd, c. Try it on your own. Pause the video, then hit play again and check with my answer. See if you get it correct. All right, by now, hopefully you have tried this on your own. We're going to see how well you did. This first monomial, 40abc squared, we can break apart into the factors 2 times 2 is 4, times 2 is 8, times 5 is 40. So this is the prime factorization. A becomes A, B becomes B, C squared becomes C times C. So this part here, this is the factored form of this monomial. Looking at the second monomial, 50, A to the 5th, B to the 3rd, C. 2 times 5 is 10, times 5 is 50. So these three coefficients, these three numbers become 50. A to the 5th is A times A times A times A times A, 5 of them. B to the 3rd is B times B times B, 3 of them. And just this C, again, would just be the 1C. Checking our common factors then, we have a 2 in each of them. We have 1, 5 in each of them. We have 1A in each of them. We have a B in each of them. And we have a C in each of them. Those are the only things that we have common to both monomials. So if we were to combine everything, multiply it out, 2 times 5 is 10, times A times B times C. So our greatest common factor is 10, A, B, C. And that'll conclude our first lesson.